Greatest Common Divisor, in short form is GCD. And definition, we are going to define what a divisor is in the GCD. And we say that a divisor is a number by which another number is to be divided, and also is a number that divides into another without a remainder. We can also list other terms used in the place of greatest common divisor. So the term greatest, what are the other keywords that are related to GCD? We have greatest, largest, highest, biggest, maximum, dividing something or a combination, cutting something into pieces, tallest, latest. All these are related to GCD. When you find a question with these keywords, then know the question is referring you to find the GCD of a number. Then, GCD is also referred to as the greatest common factor, or GCF. Also, it can be called highest common factor, that is HCF. And you have several methods of finding the GCD of two or more numbers. And the first one is listing all the factors. So, listing all the factors. Then the other method is by using prompt factorization. And the other one is using long division. Also, it is normally called using tables. The first method that we have, listing all factors. So we are going to use this method to find the GCD of numbers. So the steps are such that you list all the factors of the stated given number. So that is the first step we are going to do. So we are going to list all the factors. So the first one, which is 36. So for 36, what are that factor or numbers that can be divided by 36 without a remainder? That we can divide 36 without a remainder. 1, 36 divided by 1, we get a whole number. Also we have 2, can be divided by 2. It can also be divided by 3, by 4, by 6, 9, 12, 18, and 36. Those are the divisors of 36. Then the other number, which is 60. So let us list all the divisors of 60. 1 is one of them. We have 2, can be divided by 3. Also can be divided by 4. It can also be divided by 5, by 6. Can be divided by 10. Can be divided by 12. Also by 15. Also by 20. And also by 30, and we have 60. So those are the divisors of 60. Then the other number is 72, and also let us get the divisors of 72. We have 1, can also be divided by 2, can be divided by 3, can also be divided by 4, by 6 also, can also be divided by 8, can also be divided by 9, also by 12, so by 18, by 24, 36, and 72. So those are the divisors. Now, next step is to identify common factors. Now we are going to identify common factors. So 1 is common, and they are common. Also 2, they are common in all the 3 numbers. 3 is also common. 4 is also common. 6 is also common. All the 3 numbers. Then 9, no. 12 is common. Any other number which is common? 18, no. So those are the common factors in the 3 numbers. Now, since we have identified the common factors, now which one is the greatest common factor among them? Now we pick the greatest among the 3 factors, and the greatest is 12. The greatest is 12. So we end up saying that the common factors are, you have 1, you have 2, you have 3, 4 is common, 6, and 12. But among them, the greatest is 12. So the GCD of 36, 60, and 72 is 12. So 12 is the GCD of 36, 60, and 72. Then we move on. Method 2. Still, we are going to use the same question, but using the method of prime factors. Now the first step is to express each number as a product of its prime factors. So we have 36. So 36, we are going to express it as a product of its prime factors. In that case, if we are going to express it as a product of its prime factor, that will be 2 raised to 2 times 3 squared. Then for 60, writing it in a prime factor form will be equal to 2 squared times 3 times 5. And then 72 in terms of prime factor will be equal to 72 is equal to, that is 2 raised to 3 times 3 squared. Now we have done with the first step. That is the first step. We have actually expressed each number as a product of its prime factors. The second step is to identify common factor with the smallest power. Common factor with the smallest power. In our case, we have 2 raised to 2. We have 2 raised to 2, and also we have 2 raised to 3. But we are going to pick the one with the smallest power, which is 2 raised to 2. So we just pick one. So we are going to pick 2 raised to 2. Then the other one, the factor must be common in all the 3 numbers. So we have 3 raised to 2. We have also 3 raised to 1 and 3 raised to 2. So the one with the smallest power is 3. So therefore we are going to pick 3. So whatever we have picked, that's now what we are going to multiply. So 5 is not common in all the 3 numbers, so we ignore it. Therefore, to find the GCD is the product of the common factors that we have chosen. So GCD will be what? 2 raised to 2 times 3, which is 4 times 3, which is 12. We have got the same answer the way we have done with the first method. We move on. Method 3, we are going to use long division or using tables. So we are going to draw tables and arrange those numbers in columns. So using long division, we look for the factors which divide the given numbers exactly, starting with the least and then find their product. So here's the question: find the GCD of 36, 60 and 72. So in our case, we are going to rearrange 36, we have 60 and 72. So we make a table with the columns. Then starting with the smallest prime factors. Remember prime factors from the smallest 2, 3, 5, 7, 11 and so on. So we start with the smallest prime factor, which is 2. So 36 can be divided by 2, and we have to make sure those numbers divide them exactly. So if it doesn't divide exactly, we ignore. So we have 36. All these numbers can be divided by 2, end up getting 18. 60 divided by 2, get 30. 72 divided by 2, we get 36. Then we move on. This number again can be divided by 2. So dividing by 2, I get 9. I'll get 15. I'll get 18. This number now all of them cannot be divided by 2. So we move to the next prime factor, which is 3. All of them can be divided by 3. So by 3 I'll get 3, get 5, then I get 6. Then from there, these numbers, all of them cannot be divided by 3, so we ignore all of them. So we are going to remain with this number. Those are the factors. Therefore, GCD will be given by the product of the numbers, that is 2 times 2 times 3. We end up getting 12. Also, we have another question that we are going to find the GCD of 240, 360, 600 and 700. So in such a case, a bigger number like this, it will still be easier to use the listing method, but it will be more cumbersome because you'll have to write all the factors or the divisors. So in this case, I'll advise you either to use the prime factor method or use the long division method or the using tables. So we are going to use tables and use long division method to find the GCD. So you have 240, then you have 360, 600, 700. Now, starting with the smallest prime factor, all these number can be divided by 2. So dividing by 2, I get 120. This will be 180, 300, the one 350. Also, these numbers formed also can be divided by 2. So dividing by 2, I'll get 60, get 90, 150, I'll get 175. So if I look at this, all these numbers 60, 90, 150 and 175, 175 cannot be divided by 2. So we try the next prime number, which is 3. So if we look at it, also 175 cannot be divided by 3, but 60, 90 and 150 can be divided. So we move to the next prime number, which is 5. So if you look at all of this number, they end up with a number, the last digit can be divided by 5. So dividing by 5, we get 12, get 18, get 30, and this will be 35. So from there, all these number cannot be divided by the same number, so we ignore all of them, and then we end up multiplying the factors or the divisors. So the GCD of 240, 360, 600 and 700 is 2 times 2 times 5, which I get as 20. So that means the greatest number which can divide all the 4 numbers without a remainder is 20. Also, if you like, you can also try using the factor method to see whether you'll be able to get the same answer. Then you have an application question on GCD. This question says 3 masses of sugar are grouped into 0.36 kilogram, 0.504 kilogram and 0.672 kilogram. Find the greatest mass of sugar that can be taken an exact number of times from the 3 masses. So in this question, you have keywords. So you have greatest mass of sugar that can be divided in an exact number of times. That means without a remainder. So in this case, we have 0.636. You have the other mass and the other mass. So the first case, since they are in decimal place, I'm going to convert them to grams so that I work it out, then I will convert it later to kilogram, because the question asks us to find the final answer should be in kilogram. Therefore, 0.36. So converting them to gram, multiply by 1,000. I'll get 360 grams. The other one is 0.504 times 1,000. I'll get 544 kilograms. The other one is 0.672 times 1,000. I'll get 672 grams. So at this particular point, what I'm going to do is to find the factors. I'm going to use the prime factor method to find the JCD, or the factors of each. So I'm going to write them in factor form. So for 360, I'm going to use my calculator to make my work easier. So 360, which is the same as 2 times 2 times 2 times 3 times 3 times 5, which is 2 raised to 3 times 3 raised to 2 times 5. The other one is 544 in power form will be, we have 2 times 2 times 2 times 3 times 3 times 7, which will be 2 raised to 3 times 3 squared times 7. Finally, you have 672. 672 can be divided by 2. By 2 again. By 2. By 2. By 2. And by 3. And by 7. So I end up getting 2 raised to 4. Not 4. 2 raised to 5 times 3 times 7. And since you are finding the GCD, then we look common factor which has the smallest power. In this case, 2 is common. But which one has the smallest power? It is 2 raised to 3. So I'm going to pick one of them. Then the other one is 3 common in all the 3 numbers. Yes, 3 is common. But which one has the smallest power? It is 3. Then 5 is not common in all. 7 is not common in all. Therefore, GCD will be equal to 2 raised to 3 times 3, which will be 2 raised to 3, that is 8, and 3, which is 24 grams. But now we need to give the answer in kilograms, so we are going to divide by 1,000. So 24 divided by 1,000, you end up getting 0.024 kilograms. So that is the greatest mass of sugar that can be taken an exact number of times from the three masses. Now, the other question, which is also very, very important for us to attempt it, find the greatest number which, when divided by 181 and 236, leaves a remainder of 5 in each case. So in this particular question, since there is a remainder of 5, we need to subtract 5 from the numbers that you have been given. So you are going to subtract 5 from 181 and also 236. Then we find the GCD. Therefore, first thing you are going to do is subtract 5 from 181, which you are going to get 176, and also from 236 we get 231. Therefore, from there we find now the GCD of 176 and 231. I'm going to use the prime factor method to find the factor of 176 in power form, the same as 2 raised to 4 times 11, and that of 231 is 3 times 7 times 11. Therefore, from here, 2 is not common. 2 is not common in the two numbers. We are dealing with the two numbers, these two numbers. So 2 is not common. 7 is not common, but 11 is common. So 11 is common in both the numbers. Hence, GCD is 11. 11 is the greatest number that can be divided by 181 and 236 to leave a remainder of